So we have these four equations, and they're all quadratic equations, and we're going to expand them. So we're going to write them in standard form with no parentheses. So when we have something with a squared, we have to really treat it as we have this twice. So we're going to multiply those two together, and then we'll subtract the 4. So I'm just going to distribute the x to both of them, so I'll have an x squared minus 3x, and then I'm going to distribute the negative 3, so negative 3x plus 9. I still have this minus 4. I'm going to combine like terms, so I'll have a negative 6x and a plus 5. So this is my new function, f of x equals x squared minus 6x plus 5. Okay, so that's the standard form. I'm starting with the highest power and going down. So these two equations would be equivalent. They graph exactly the same way. Any x value for one equation is going to give you the same output for both equations. So next one, we do have this negative 3 out in front. I still will write this x plus 2 twice. Okay, and you can decide what you want to multiply together first. I prefer to multiply the two parentheses groups together, but you could distribute the negative 3 to one parenthesis group. So, and again, you could also multiply these out with a box. I'm going to use the parentheses because I still am multiplying by this negative 3 afterwards. So if I distribute the x to both of them, I'll have an x squared plus 2x. And if I distribute the 2 to both of them, I'll have a 2x plus 4. All right, so I can combine these middle terms, but I also am going to multiply that negative 3. I'm going to do this together here. So negative 3 times the x squared, I get a negative 3x squared. This becomes 4x, so when I multiply by this, I get a negative 12x. And then here I get a negative 12, and I still have this plus 3. So when I combine like terms, those last two will combine to be a negative 9. So my function is as follows. Okay, so again, same exact, I could test it out. I could put a value of x in one equation to one function, and then it should also be the same thing as the other one. Okay, and these last two are in factored form. So if I multiply them out, again, I'm just going to distribute the x to both, so x squared minus 5x. Then I'm going to distribute the negative 1, so negative x, positive 5. We'll combine like terms, so x squared minus 6x plus 5. In this one, again, we can decide what to multiply together first. I like to do the parenthesis groups. So here I'll distribute the x. Then I'll distribute the 1. I'll combine like terms and also distribute this negative 3. So I'll have a negative 3x squared. This becomes a 4x. When I multiply, I get a negative 12x and then minus 9. So I don't know if you noticed here, but these two answers are the same. And these two answers are the same. And that's because this right here is called our vertex form. This right here is our standard form. And then down here, this is the factored form. Each one of these gives us something specific about our graph. Now, not all quadratic functions you can put into all three of these forms, especially the factored form is kind of a specialty, but all quadratics do have a vertex, so you definitely can put them in vertex form, and then also you can put them in standard form. Sometimes it's still like the same way because you might be having one of your values here. So if I look at this example here of these different ones, so generally our standard formula, or standard form, we could say for this is going to be just an ax squared plus bx plus c. And we have values for a, b, and c. A always has to have some kind of value there, but sometimes we might be missing one of our other terms. So if we look at these examples up above, I'm just going to use the first one, that f of x. So an example of this, we would see this standard form looking like this x squared minus 6x plus 5. Our factored form, we see these factors in here. So typically this a value is factored out. Okay. X minus p, x minus q. Okay. Now this is a little bit more general too, because we could have coefficients in front of x. Sometimes we don't. But in this example then we had here, our factored form was when f of x was x minus 1, x minus 5. That a value was just 1. We didn't see a number out there. And then our vertex form, this generally looks like a x minus h squared plus k. And so for our first one, that was this x minus 3 squared minus 4. Okay. And we found out all these would graph to be the same thing. So if we look at the characteristics that make up the graph here, for the standard form, we get our y-intercept really easily. And that y-intercept is that constant value. So in this case, that 5 is going to be our y-intercept. In our factored form, we can see our x-intercepts really easily. And we get that really from setting our factors equal to 0. So when we look at this, we're looking at the x minus 1 equals 0 and the x minus 5 equals 0. And so in this case, we get x values of 1 and positive 5. Okay, so these are our x-intercepts from there. So we do see that sign change because we're solving that equation. That's one reason why in that factored form I wrote it as x minus p and x minus q. Again, sometimes there's coefficients of x's, so sometimes we have to divide those. And then the last one, we're seeing a vertex. Hence the fancy name of vertex form. And for this, what we're going to end up seeing here, now if I look on the graph here and I have these two x-intercepts, I know that my vertex should be somewhere in the middle of them. And in the middle is a positive 3. So that comes from this. We have this positive 3. Okay. And we could always test it by putting 3 into any of these functions and seeing our outcome. But what's going to end up happening is in this vertex form, we get a 0 in those parentheses. And so we're left with the negative 4 as our outcome. So our vertex is really that HK. And that's why we see that opposite sign by H, where it says x minus H. So here's our vertex. So we see this parabola coming together. I have that one hanging y-intercept in there. It will reflect over on the other side, so we'll have, because this is all has symmetry, so I could reflect it to that point over there. But this is what my parabola will look like. So each form has its perks. It tells us different things about our quadratic function here. Now sometimes there's some overlap, like if our vertex is on the y-axis or if our vertex is on the x-axis, sometimes you're going to see some of these forms look almost identical. And so you can't have a really different form. Now also we could have a quadratic function here that does not cross the x-axis. And in that case, it would not be in factored form. It would not be possible. Or sometimes, too, it crosses the x-axis at irrational values, and so we can't factor it either. So these three ones we're really exploring in our quadratic, and we're looking at how we can put it into that vertex.